Welcome dear students. Today in this video lecture we are going to discuss topic symmetry. This is a chapter that comes under your term second syllabus, and in this chapter we will discuss what is symmetry, line symmetry, and we will also discuss rotational symmetry, and we will also discuss the order of rotational symmetry. Now starting with the definition of symmetry. Symmetry is when an object has two or more equal sides when split in half or in smaller pieces. That is, when an object has two or more equal sides. Now here you can see that this is an image of a tiger, face of a tiger. Now if I draw a vertical line through the middle of the face gets divided into two parts that match each other. Now these two parts on the either side and the two sides of this line, vertical line, are identical to each other, and this tiger has a line symmetry, that is, these two parts are symmetrical about the line, vertical line. This is called as symmetry, that is, these two parts are identical to each other, that is, these are mirror images of each other. This is called as symmetry. Now what is line symmetry? A shape has line symmetry when half of it is the mirror image of the other half. That is, one half is the mirror image of other half. Now you can see from image here that given on the screen, if we draw a horizontal line here, if I draw a horizontal line like this, now the two figures on the sides of the horizontal line above it and below it are matching each other. They are identical to each other, that is, they are symmetrical, and this is called as line symmetry. When the two parts of the object, when the object on the both sides of the line are matching each other, it is called as line symmetry. The line may be horizontal, vertical, or it may be diagonal, as in case of geometrical figures. To be a line of symmetry, the shape must have two halves that match exactly. That is, for a line symmetry, the shape must have two halves that match exactly. Like in case of this heart, we have drawn a vertical line of symmetry here. Now the two sides, that is this side and this side, these are matching each other. These are identical to each other, and this is an example of line symmetry. Now you can see that which of these flags have a line of symmetry. Now you can see from the figure that this first one flag, US flag, has no line of symmetry, because if we draw either vertical or horizontal line, the two parts don't match each other. That is why it has no line of symmetry. Now this flag of Canada, it has one line of symmetry, because if I draw a vertical line through the middle of this flag, the two parts on the either side of this line are matching each other. That is why it has line symmetry, one line symmetry. Now this Maryland flag also, it doesn't possess any line of symmetry. Now this flag of England, it has two lines of symmetry, one vertical. If I draw a vertical line here, the two sides are identical. Also, if I draw the horizontal one, the two sides above it and below it are also identical, same, that is, they are matching each other. This is called as line symmetry. Now coming to the examples of alphabets, symmetry with alphabets. Now you can see that alphabet, capital alphabet A has one line symmetry, that is vertical line. M also has one line of symmetry. U has one line of symmetry. Also W has one line of symmetry, that is, the two sides on the two sides of the alphabet, the two parts of the alphabet on the sides of the line are identical. Also letters E, B, C, D has one horizontal line of symmetry. You can easily see it from the figure. Also, square has four lines of symmetry. When we come to the geometrical figures, a square has four lines of symmetry. That is, one vertical, the two parts are identical on the sides of the vertical line, one horizontal, diagonal, second diagonal line of symmetry. That is, if I draw a diagonal line like this, now the two sides, this side and this, divided into two triangles. These triangles are identical, superimposing on each other. That is why they are symmetrical. Also, circle has infinite lines of symmetry because through the center of the circle we can draw infinite number of diameters. That is why it has infinite lines of symmetry. Here each diameter is a line of symmetry. Now through this point, through this center point, we can draw infinite number of diameters. That is why a circle has infinite lines of symmetry. Also, in case of rectangle, a rectangle has two lines of symmetry. It is self understood from the figure. One line of symmetry horizontal and second vertical. Now, what is rotational symmetry? Now we will talk about rotational symmetry. A figure is said to have rotational symmetry if it fits onto itself more than once during a complete rotation, that is, rotation through an angle of 360 degree. If I am rotating my figure through an angle of 360 degree, now how many, if if it fits onto itself more than once during a complete rotation, then it is said to have a rotational symmetry. Now, if an image has rotational symmetry if there is a center point around which object is turned or rotated a certain number of degrees and the object still looks the same, that is, it fits onto itself, that is, it matches itself a number of times while it is being rotated. Here we have to rotate it through 360 degree, through 360 degree, that is one complete turn or one complete rotation. You can see that this triangle, when rotated through 360 degree, it fits onto itself three times as it is rotated. Therefore, it is said to have a rotational symmetry of order 3. Now, what is the order of rotational symmetry? We will discuss it. Coming to the order of rotational symmetry, the number of times a figure fits onto itself in one full turn is called the order of rotational symmetry. That is, how many times during one full turn the figure fits onto itself. This is known as order of rotational symmetry. If you see that this triangle fits onto itself three times when rotated through 360 degree. Here it fits onto itself, here also, and here it will also fit onto itself when rotated through 360 degree. And during this rotation it fits onto itself three times. That is why it has rotational symmetry of order 3. Now, taking this example of pizza, since all the toppings are placed so evenly, that is, each and every topping, these toppings are matching each other, this pizza has rotational symmetry of order 6. That is, we can rotate, when rotated through 360 degree, that is one complete rotation like this, when rotated through 360 degree, when I am rotating it through 360 degree, during this rotation it fits onto itself 6 times, because each time when I am rotating it through 60 degree, that is this angle, it fits onto itself, and 6 times it fits onto itself when rotated through 360 degree, that is through one complete rotation. That is, it has order 6 of rotational symmetry. Also, this flower has rotational order of 5 because it fits onto itself 5 times when rotated through 360 degree. During this complete rotation, it will fit onto itself 5 times. Now, taking the example of this hexagon, let this be starting point and let us rotate it through 360 degree. We will rotate it step by step. Now this is a rotational point. This yellow dot, let this be reference point. Now rotate it once. This dot will come here, yellow dot. Now it fits onto itself when rotated through this angle. Again rotate it twice. It looks same as it was before. Rotate it 3 times. Again it will fit onto itself 4 times. Again it will fit on itself. Rotate it 5 times again and rotate it 6 times. It will come back again to its original shape. So it fits onto itself again. So hexagon has order of rotational symmetry 6. It is written here because it can be rotated 6 times to cover it exactly, to cover itself exactly. That is, each and every time it superimposes onto itself. That is the case of order of rotational symmetry. Here are some real life examples. That is the example of starfish. Now you can easily say that it has an order of rotational symmetry of 5. That is, the order of rotational symmetry here is 5 because when rotated through 360 degree, each and every time when rotated through this angle, that is 72 degree, it fits onto itself. It will fit onto itself. It is 1, 2, 3, 4, 5.